Good morning, everybody. Welcome to another wonderful morning of Chem 1105 with your host, me, Dr. White. And if you don't know, it's Wednesday the 13th. Oh no, Wednesday the 13th. Wait, that's Friday the 13th. Shucks. If you look at the calendar, which I just did, we don't have any Friday the 13th classes this semester because there's no Friday the 13th between now and the end of the year. But for those of you who are interested, if you stick around after class today, I'll tell you my Friday the 13th story, which I will cut out of the video. All right, important announcement. This Wednesday, I got Wednesday on the brain. This Friday, I will be giving test number 2 during our lecture time. At about 9:55, I will email you the password for which version of test number 2 you'll be taking. Sometime tomorrow, I think 10 o'clock a.m. I have it already set up to be visible for you. Test number 2 will be available and visible to you in the assignment area of Blackboard. You can download it, but it's a password protected PDF file. Say that 5 times quickly. No, I won't. But anyways, don't forget, just like test number 1, you will have until 11:30 to take test number 2 and then upload your answers in a single PDF file to the assignment area of Blackboard. And as I mentioned already, if you don't do it in a single PDF file, I reserve the right to take off 25 points from your test score. I will have the files, how to make a single PDF file. They've also been available to you for every lab, and you should be able to do that. As I've already posted and sent an email to you, test number 2 will be on chapters 4 and chapter 5, part 1, which we've already done all the practice problems. But as soon as I'm finished doing my introduction here, we'll do my world famous review for the next test, test number 2. So, any questions so far? And for those of you who logged in yesterday, Monday, I mentioned that there was no class yesterday because it was in service day, which meant I got swamped with a lot of personal stuff, which is why Monday's video hasn't been posted. It'll be posted sometime today, along with today's video. All right, let's get going. All right, what you see on your screen, test review, test number 2, Chem 1105, is also cleverly hidden in the lecture section of Blackboard for Chem 1105 called test number 2 review. All right, let's get going. You should know how to do Lewis structures for elements. How do you do it for an element? You write down the symbol and then 1 dot per valence electron. And you do 1 on each side before doubling up. This is for elements. And by the way, let me open up something quickly. And you should all see on your screen the periodic table. Remember, the numbers in red on top tell you how many valence electrons each element has, which you did on test number 1. Carbon has 4, oxygen 6, chlorine has 7. And also the alkali metals, lithium, sodium, potassium, and also hydrogen, which is not an alkali metal, have 1 valence electron. Now, you should know that there are two types of chemical bonds. Those are the forces that hold atoms together in what we call molecules. And the first one you should know is an ionic bond. And that's the transfer of one or more electron or electrons from one atom or group of atoms to another atom or group of atoms. That's an ionic bond. Give you time to write that down, or you can download this file and read it on your own. You should also know what is a covalent bond. And a covalent bond is the sharing of one or more pairs of electrons between atoms. So a ionic bond involves transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. And a covalent bond involves sharing of one or more pairs of electrons between atoms. Don't forget, pair means two. Now, this will not be on the test, but I thought I'd remind you the octet rule. In compound formation, making molecules, atoms and elements lose, gain, or share electrons to get 8 valence electrons. Same number of valence electrons as the nearest noble gas. And I'll never ask that on test or final. Now, if a if an element loses or gains electrons to form its octet, we make ions. And positive ions are formed when an element loses one or more electrons. And negative ions are formed when an element gains one or more electrons. And note, elements lose or gain electrons. They have the same number of electrons as the nearest noble gas. Deja vu all over again. I just said that. And elements never lose protons when forming an ion. Same thing with neutrons, but it's important to know that for protons. And let's just do one real quick. And the question would be, what ion does sodium form? And sodium has 11 electrons and 11 protons. How do you know that? From the atomic number in the upper right-hand corner of this periodic table, which you will download, and this is the one you should use for test number 2, 3, 4, and the final. And if we notice, what's the nearest noble gas? And how do you determine nearest? By what's the one closest numerically based on atomic number. Sodium at 11, you have neon at 10, argon at 18. Neon is 1 away, argon is 8 away, which is a smaller number. And time's up, hopefully I'll pick 1. So what does that mean? To determine what ion sodium will form, it has 11 electrons, 11 protons. It will go to the ion where it has the same number of electrons as the nearest noble gas, 10, but it will still have 11 protons. Each electron is a -1. Each proton is a +1. So this is +11, -10, add them together, you get +1. To show the ion, you have the symbol, and then superscript right, you have, if it's a plus charge, just 1, you just show the plus charge. If it's, say, calcium, which shows a +2, I like the old method, or you can also, or better, instead of or, and you can write, which I don't like, but that's my personal 2 plus. So that's how you form an ion. These are cations. If it was negative, those would be anions. And you should know how to do that. And remember, all molecules have a net zero charge. So if I asked you to write the ionic formula from ionic charges, what would be the simplest, or I could also say empirical formula with a molecule containing calcium +2 and chloride -1? Well, this is a +2, this is a -1, and that line should be over here. It should be a 0 with a line through it. It doesn't, so you can't change the charge, but you can change how many of that ion is present. Here, if I have 1 calcium, 2 times -1 would give me 0. So that tells me I have 1 calcium and 2 chlorines. And remember, for polyatomic ions, if you have more than one, you put it in a bracket. Oh, let me share some fun with you. What is the empirical formula that has magnesium plus, for the molecule that has magnesium +2 and NO3- nitrate -1? Your turn. Have fun. And while you're doing that, remember, since we had no lab yesterday, the lab we did last week is not due yesterday, but next week. And remember, henceforth, ooh, fancy word from Dr. White, henceforth. Look out, I'm getting fancy on you, pulling out the 25-cent words, or now with inflation, the $5 words. But anyways, henceforth, if you don't get it in on time, I will take off late points. If you're more than 8 days late, you will get 0 points. Please hand in the labs. I don't want to have to do that. Pretty please? All right, let's do this. This is a +2. This is a -1. How do we know? Right here and right here. This has to add up to 0. I got the line through it finally, but it doesn't. I can't change the charge, but I can change how many. So I'm going to put a 2 there, and now we'll add up to 2, because 2 times -1 is -2 plus +2 will give me 0. So I have 1 magnesium, because there's only a 1 there, but how do I do 2 of these? Well, it's a polyatomic ion, which nitrate NO3- is. You put it in a bracket, close the bracket, and subscript, right, you put this number. In this case, it's 2. And that's how you do it. And Ruben, you're correct. And Sergio, thank you for helping me out. Once in a while, when I'm zeroing in on lecturing, I forget in Zoom to look at the chat. When I'm lecturing in a classroom, I look at the class. But since most of you don't have your videos on, I don't. That was chemist guilt. Did it work? All right. Next, I talked about covalent molecules, and you should know there's 3 types of covalent bonds. And if we were in class together, I'd say it's class participation time, but we're not, so I'll do it alone. but you can do it at home if you want. And that is, what are the three types of covalent bonds? And the first one is a single bond, next one, double bond, and final one is triple bond. And you should know that a single bond has one pair of electrons, a double bond has two pair of electrons, and a triple bond has three pair of electrons. Let's do it again. What are the covalent bonds that hold atoms together in molecules? And first of all, single bond, one pair, double bond, two pair, triple bond, three pair. And by the way, I think you should know that the air you're breathing contains nitrogen and oxygen gas, which the atoms are held together by covalent bonds. The water I drink and you drink too, hydrogen oxygen atoms are held together by covalent bonds. But sodium chloride, table salt, please pass the NaCl, is an ionic compound made up of sodium cations and chloride anions. All right, you should know how to draw the Lewis structures of molecules. And here, unlike elements, you can't have more than two dots. And the first thing you have to do is find out how many valence electrons each type of atom in a molecule has. And then you start and make sure it follows the octet rule. And I'm going to let you have one. Hydrogen cyanide, HCN, is, a molecule, and 3 points each. And it's your turn. Draw the Lewis structure for that. I will give you a big hint. Carbon's in the center. And also, what kind of bond exists between carbon and nitrogen and hydrogen cyanide, HCN? I think everybody's done. By the way, does anybody know a good source? Send me by email if you do, for a wave file, something like from the music from The Price is Right or some other game show. I should play that while you're doing these problems. Maybe not. All right, let's do this. Carbon's in the center. It has 4 valence electrons. Hydrogen has 1. Carbon, not carbon. Nitrogen has 5. And this hydrogen looks at one of these electrons, and carbon says, I've got 1 electron, valence electron. You have 1. Let's share. And they do. And then left over, because this is spoken for now, carbon has 1, 2, 3 single valence electrons left over. Nitrogen has 1, 2, 3 single electrons, valence electrons. And this carbon says to the nitrogen, hey, would you like to share electrons, pairs of electrons? And nitrogen says, of course. But you didn't know atoms can speak. At least in my head, they do. And here it is. Now, if we look at hydrogen, it has 2 valence electrons, one of its own, the other sharing from carbon. And the exception to the octet rule is hydrogen. Its octet is 2. Now, if we look at nitrogen, carbon, it has 2, 4, 6, 8. And it's got an octet. And if we look at nitrogen, it has 2, 4, 6, plus here the 2 non-bonding, and it has 8 valence electrons. Now, what do we call the bond between carbon and nitrogen? Well, how many pairs of electrons? 3. That's a triple bond. And one more thing I want to show you. If I were to do this, and ask you, and I'll do this one. All alkali metals and alkaline earth metals never form covalent bonds. All alkali metals, sodium, potassium, and lithium for this class, and all alkaline earth metals for this class, magnesium and calcium, never form covalent bonds. They form ionic bonds, and the alkali metals always form a +1 charge. Now, oxygen has 6 valence electrons. Hydrogen has 1, so it shares it. But now oxygen only has 7 valence electrons. How can it have an octet? This electron from sodium goes to oxygen, and now it forms the hydroxide anion. So sodium hydroxide, NaOH, has an ionic bond and a covalent bond. And a lot of molecules in nature and our daily life have both in the same molecule. If you use soap today, and I'll teach you this later this semester, that has both ionic and covalent bonds. I should mention, when you wash your hands or anything else, you're doing serious organic chemistry, which I'll teach you later. All right, next I talked about chemical equations. Chemical equation like A plus B makes C. You have an arrow. At the base of the arrow, A and B are the reactants, which sometimes I'll call starting materials. C and anything else is a product or products. I talked to you about how to balance a chemical equation. You have to have the same number and the same type of atoms of each element on each side. And we did this. You did a lot of practice. By the way, there will be, I think, 3 or 4, I forgot which right now, balanced chemical equation questions on test 2. On test 2 and the final, where I'll give you balanced chemical equations, I will. Lost my train of thought there. The answer already balanced will never, ever be correct. If I asked you to balance a chemical equation, you're going to have to do it. All right. As I taught you, you can only change the coefficients, not the chemical structure. Students try and do that. It's always wrong. My advice to you is leave hydrogen and oxygen atoms to balance last. And remember the even odd trick or methodology that I taught you. Next, we started talking about the mole. And Dr. White was very happy. Yes, I was. And the mole is the chemist's counting unit. Another way of saying a mole is Avogadro's number of atoms in an element, or other ways. But when you think about a mole, you should know how to use 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms. 1 mole of a compound equals Avogadro's number. Ooh, the 2 fell off there. Uh-oh, this has been attacked by the dreaded 2 virus. Sorry about that. 6.02 times 10 to the 23rd molecules. Also, 1 mole of an element is the atomic weight of that element. Don't forget test number 2. Under your name, it'll say, please use proper significant figures for all calculations. And it will also say now, please use 3 significant figures for all atomic weights. If you don't, I'll take off a point. And finally, 1 mole of a compound equals the molecular weight of that compound. Before test number 2, while you're studying, I would highly recommend you look at test number 2, important information. This is stuff that will be on the last page of test number 2 that you either print out or look at on screen, however you take the test. And these are things students used to have to memorize, but for now, over 2 years now, 2.5 years, I came to the conclusion, I just want to test your knowledge of using this in a chemical question, as opposed to also testing how good your memory is. And these are all things I've talked about. And if you notice, 1 mole of a compound is the molecular weight of that compound in grams, and the molecular weight of the compound is the sum of all atomic weights. We've done this, practiced this. Now, you should know how to convert, and these are all things we've done, moles of an element to atoms of an element, or going the reverse, atoms of an element to moles. Moles of a compound to molecules of a compound, and also molecules of a compound to moles of a compound. These first 2, you would be using these first 2 and either atoms or molecules of Avogadro's number. And don't forget to use your, oh, I've got to do it, your good buddy, your good friend, unit analysis. I love that whistle. For those who don't like it, send me a nasty email. Also, you should know how to go from mole of an element to grams of an element and back, and from moles of a compound to grams of a compound back. And it's not on this list, but you should also know, because you'll need to know, how to determine the molecular weight. MW is short for molecular weight of a compound. I just realized, can everybody read where I have element and compound on the screen? If you don't, email me. I don't know if I'll have time to change this. And remember, use unit analysis. We've done it enough times. If you're not sure how to use this or anything I've talked about, don't forget, today is Wednesday, and I will have my office hour from 5 to 6:15 on Zoom. You don't even have to get in your car and come to COD. Such a deal. Thank you, Dr. White, and thank you, Zoom. All right, next I talked about mass calculations for reactions. And here, remember, convert the mass of A to moles of A. Whatever you're given in grams, you convert to moles. Then you convert the moles of A to moles of B. And finally, you convert the moles of B to grams of B. What's the important concept to use? Well, for step number 2, remember the coefficients of a balanced chemical equation are molar ratios. The coefficients of a balanced chemical equation are molar ratios. Uh-oh. The end. Well, I'm not done today yet, but let me put a question out to you people. It's going to say, are you done? But pretend instead of saying, are you done? Was the review helpful? Yes or no? And let me send it out to you now. Again, answer, was the review helpful? Well, it looks like most people think it was. Well, that's why I do it. All right, let me do one more thing helpful for you. All right, everybody seeing problem 4 on your screen? Give me a thumbs up if you see it. Wait, better yet, now you should see it. Everybody see it? Thumbs up, people. Wake up. Thank you, Elena. All right, let's go through this once more because I think this will help you. All right, you're given a balanced chemical equation and you're asked how many grams of C3H8 propane are needed to make 24.6 grams of CO2. We're trying to find grams of propane, C3H8. We're given grams of CO2, carbon dioxide. There is no way you can go from grams of a compound to grams of another directly. You need 3 steps. And if we look at important information, this is a mass calculation, mass mean grams for reactions. Hint, you'll be given a balanced chemical equation to do this type of problem. First step, you go from mass of A to moles of A. Second step, moles of A to moles of B. And third step, convert moles of B to grams or mass of B. So let's take a look. First step, we have 24.6 grams of carbon dioxide. We want to get the moles of carbon dioxide. Whatever we're trying to get to, because you're using your good buddy, your good friend, unit analysis, goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Where do we get the numbers? 1 mole equals the molecular weight of a compound. So now we have to figure the molecular weight of carbon dioxide, CO2. You have one carbon at 12 and two oxygen. I combined this step. Each oxygen is 16.0, which gives you 32.0. And the molecular weight of carbon dioxide is 44.0. Don't forget, when you're adding, you have the same number of significant figures to the right of the decimal as the number you're adding that has the fewest significant figures to the right of the decimal. In this case, 12.0, 32.0, both have one significant figure that's that 0 to the right of the decimal. Remember, all zeros after a decimal point are significant. And if we do the math, but before we do, grams of CO2 divided by grams of CO2 cancel out. We're left with moles of CO2. And this is three significant figures. The one is an exact number. The CO2 grams is 3. My answer is 3 significant figures. Remember, there are two ways of rounding off on a multi-step problem like this. One is at each step, and I am an each step person, or you can do it all at the end. I will calculate both ways for test number 2, and both answers rounding off each step or at the end, if they're different, will be correct. Well, now I have moles of CO2. Now I'm going to do step 2, go from moles of A to moles of B. A is CO2, what we've been given. We're trying to get to grams of C3H8. So I want to get first to moles of C3H8B. So I have moles of CO2. I want to get the moles of C3H8 propane. You know, that's stuff in the white tank for your barbecue. And I'll use our good buddy, our good friend, unit analysis again. Whatever we go to goes on top. Whatever we're trying to get rid of goes underneath. Where do I get these two numbers? From the balanced chemical equation. The coefficient, the number in front, tells me molar relationships. And for this balanced equation, when there's no number in front, it's 1. So this tells me there's 1 mole of C3H8 reacting with 5 moles of oxygen to make 3 moles of CO2 and 4 moles of water. If I'm looking for a relationship between C3H8 and CO2, that relationship, molar relationship, is 1 mole of C3H8, coefficient there, when you don't see one is 1, makes 3 moles of CO2. 1 mole of C3H8, 3 moles CO2. And therefore 1 mole C3H8, 3 moles of CO2. Now this is 3 significant figures. The 1 and the 3, the moles from the molar ratio of a balanced chemical equation are exact numbers and do not play a role in how many significant figures you get. So if this is 3, these are exact numbers, I get 3 significant figures, and this is my answer. Again, you can round off at each step or at the end. And I'm an each step person. Now, are we done? No, we're trying to get the grams of C3H8 propane. We have moles of propane, C3H8. So now we do step number 3, and let's go from moles of B, C3H8, to grams of B, C3H8. And here we have moles of propane, C3H8. We want to get the grams of propane, use unit analysis, grams of propane, C3H8, goes on top, moles of C3H8 go underneath. Where do I get this relationship? Well, in case you forgot, important information, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights in grams. So if I start this, I'm trying to go to grams of C3H8. I'll use unit analysis again. What goes on top of the ratio, what I'm trying to get to, grams C3H8. What am I trying to get rid of? Moles of C3H8. And where do I get this relationship? 1 mole of compound equals the molecular weight of C3H8. Well, you've got to figure that out. Molecular weight is the sum of all atomic weights. Over here, just under step 3, I have the calculation. 3 carbons, 8 hydrogens. Each carbon is 12.0 atomic weight to 3 significant figures. Each hydrogen is 1.01 to 3 significant figures. Do the math, multiply 3 times 12.0 and 8 times 1.01. Here are 2 numbers, add them up. Notice the first number, 36.0, has 1 past 1 significant figure. Past the decimal, 8.08 has 2, so I should have 1. Keep the 0, use the 8 to round off. It's 5 or higher, drop it, increase the number by 1 in front. So the correct answer using 3 significant figures, or correct answer using 3 significant figures for the atomic weights is 44.1. I put that in there, 3, exact number 1, and I get 3 significant figures. Now notice I have 8.20 grams or 8.22 grams. The or is if you round off at the very end. So you can get different numbers. But I've done these calculations where I'm dealing with a couple $100,000, yes, a couple $100,000 in chemicals, and the 3 significant figure at each step has never failed me. And good habits, Dr. White doesn't break. All right, let me do this. First of all, does anybody have any questions so far about anything? I still haven't figured out the meaning of life, but a lot of other things I do know the answers to. Like Avogadro's number, 6.02 times 10 to the 23rd. No questions? Let's do one more little practice to help you out for Friday. Remember, we won't have a lecture on Friday. This you'd have to find out on your own, but I'm going to help you out. Question is, how many grams? Oh, that's wrong. Hold on. Quick repair job there. How many moles of water are 1.876 times 10 to the 5th grams of water? And I also, for now, you'd have to look this up Friday from your green periodic table, but the atomic weight of hydrogen is 1.01 and oxygen is 16.0. And a quick commercial from Dr. White. After lecture day, those of you who want to stick around, I'll tell you my Friday the 13th story. It's true and it's really scary. Not really. About the scary part, the true part, yes. And I'll sit here patiently. Waiting for you to finish. Come on, finish. And when you're done, give me a thumbs up. Let's see if you people are in the mood to do that today. I see one person has. All right, I think just about everybody's done, so I better get to work. What are we being asked to find? Moles of water. What are we given? 1.876 times 10 to the fifth grams of water. This is the only thing we have to start with, so I will. If I had some ratio, what would I want the units of my answer to be? Moles of water. And now use my good buddy, my good friend, unit analysis. Anybody keeping count? How many times I say that? Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And where do I get these numbers? From 1 mole of a compound equals the molecular weight. And the molecular weight of water, 2 hydrogen. I'm going to go through this real quick. 1 oxygen. And you get 18.0. This is 4 significant figures. This is 3 significant figures. This is an exact number. So my answer should be an exact number. And if you don't know how to use your calculator for scientific notation, please see me tonight. And my calculator gives me this wild number. And rounding off the 3 significant figures, keep the 1, keep the 0, keep the 4. Use that to round off. It's 2 or less, so I drop this. So the correct answer is this. And you should know how to do this. With that, oh, I'm sorry, I went a whole 60 seconds late. Bad, Dr. White. I'm going to say goodbye, and then if those of you want to stick around Stick around for my Friday the 13th story. So I'm going to say goodbye first. Gang gesund, goodbye. I stole that from Granny Beverly Hillbillies. Look it on YouTube, it's there. And with that, you can run away. If not, it's time for a Dr. White Friday the 13th story.